Hello, guys. I just wanted to help you guys out with your homework just a little bit. Let's see if we can pull it up here. See if I can share the screen with you. Where would it be? Is this it? I think this is it. Let's do it real quick like. Get out of the way. Get out of the way. Oh, this thing. Ooh, let's see if that works. Okay. Real quick, we'll do number one. Hopefully, I don't have to write anything down too much, and this will help you. All we're talking about, we've been doing discrete random variables, continuous random variables, and now we're actually doing what we call transformations. And all I'm asking you guys to do is basically look at your notes that we had done a little bit before. When you're adding or subtracting, to a random variable, the shape stays the same. The center is going to go up or down depending on what you're subtracting or adding, which, what does that mean? The center, the mean, and the median. Variability, the range, the IQR, things that we actually did in chapter one, chapter two, it's going to stay the same as well. What happens when you multiply something to the random variable that we started with? Well, the shape again stays the same. The center, which is your mean and your median, it's going to multiply or divide. And then your variability is not going to stay the same anymore. It's actually going to multiply or divide by whatever, that number, in this case, constant C is. We'll talk about variance a little bit more a little bit later, not in this homework. So if I said let random uh, variable x be a discrete random variable, and the y is the transformation of the x. So what we've kind of been talking about, right? Tell me what the shape would be, tell me what the median would be, and tell me what the range. And all I'm asking you guys really to do is to look at your homework. Well, it looks like here y is going to be the result of random variable x being subtracted from 18, or 18 being subtracted from x. Well, what happens to the shape? Well, look back at your homework. Okay. Oh, the shape, and when we add or subtract, stays the same. Okay, that's pretty easy. All right. What about the median? Well, does the median change? Well, the median, oh, yes, it's going to go, it will not stay the same. It's going to add or subtract. In this case, subtract 18. So y, whatever y represents, is going to be 18 less than the discrete random variable x. And then the range, well, when we add or subtract, variability is the range, so it won't get affected at all. All right, part B. Part B says, well, y is now, we're not adding or subtracting. It's 1.5 times whatever, the probability distribution of x actually is, right? Well, what happens to the shape? Well, if you go back to look at your notes, all right, the shape will stay the same when we multiply or divide. This is where I'm at. See it? Okay. The center, the mean, and the median. Well, the mean will get multiplied 1.5 times that of x. So y is going to be 1.5 times whatever x represents in this situation, right? And then the variability, which is, what will they say? The range. I think they said the range here. Yeah, and the range, same thing. 1.5 times whatever x is. That's what y is going to be. It's going to be an increase. The range will get affected by this here, right? And that's all over our notes right here. Oh yeah, range right here. Yep, there it is. Okay, all right, let's go on down to B and let's do some actual mathematical examples with this. The number of patients seen by a dental hygienist on a given workday can be modeled by the random variable X. All right. And here it is right here. So, I got 7 patients, 8 patients, 9 patients, 10 patients, 11. The probability me selecting one of these patients, 0.17, whatever. And we've already done, this means the mean, the expected value of the um, uh, random variable X is 8.83. And we know how to interpret that, right? Standard deviation of this scenario, the give or take 1.2, right? 3. All right. And here is the distribution here. Here is the graph of it, right? Number of patients. And we can put that in our calculator if we wanted to, right? So X was 7. I put 7 under L1. And then what's that? 0.17 for L2, right? And we know how to do that. And we go into our stats and we calculate that data, right? We've done that before. Okay. Suppose each patient is scheduled for a 30-minute appointment. Okay. So each patient, so one patient, 30 minutes, 2 patients, right? 3 right? So all I'm doing is multiplying by the random variable X, whatever it is, by 30. Okay. Y is going to represent the number of minutes a dental hygienist is scheduled to treat patients on a randomly selected workday. For a dental hygienist who sees 7 patients in one day, how many minutes is the hygienist scheduled to treat patients? Well, so I got 7 patients, 30 minutes apiece. How many minutes would that be? Am I allowed to multiply? Sure. 7 times 30 is 210. So part A, wouldn't that be 210 minutes? Yeah, no big deal. Okay. Complete the probability dish. In other words, fill it all out. So this part would be 210. What would the next, and the probability is going to stay the same. Okay, probability is going to stay the same. 8 times 30, 240. 9 times 30, 270. 10 times 30, 300, right? And those are all in minutes right there. And so we should be able to fill out that with the same kind of probability distribution like we've done before. All right. Well, how does the shape of the probability of Y, how does it compare to X? Well, let's look at it up here. We got unimodal type of distribution, whatever. When I multiply, what does that shape look like? Well, if I go back to my notes, when I multiply or divide, the shape is going to stay the same. So that's what we're going to put. Hey, get out of there, get out of there, get out of there. The shape is going to stay the same. I wish I could hide that. I don't know how to do that. There we go. Give a reason for your answer. Anytime we multiply or divide, probability distribution, the shape, whether it be normal or whatever, it will always stay the same. Find the mean and the standard deviation. All right, so really what you're going to do, all right, if you can see my calculator, hopefully, go back to your stat. All right, we're going to go edit, okay, and we're going to put over here all of my X values, 210, whatever it was. I don't remember what the next one was, 280, 300, 3, whatever. All of those go in for my X values, which is the number of minutes for my brand new distribution. Why is it brand new? Because I multiplied everything by minutes. And I'm going to get a brand new mean and a brand new standard deviation. And you should know how to do that already. All right. Part E, let Z represent the number of hours. Oh, okay. So really, I'm going to take the mean, right, and divide it by, how do I get, minutes converted to hours? Let's divide everything by 60, and we should get our answer from there. Should get our answer from there. I think that's right. Find the mean and standard deviation of Z. Oh, okay. So after, give me the average or expected value and the give or take from that. Okay, so that should be very, very straightforward. Again, might have to look at that one on the board where I can write some stuff down on that one. Okay. All right, let's go on to the next one. Hopefully, you guys will pay attention and know how to do this on your homework. I might go back to letter E. I might do that one in the classroom. That's a good one. Uh, let's see. The number of words typed per minute, WPN, by the general adult population follows a distribution that's approximately normal. I like it when you guys highlight those stuff. That's really good. It's got an average of 52, standard deviation, give or take, 16.7 words per minute. Some people do, a round average, which is what, around 30, I don't know, six. And some people do a little bit more than that, almost 68 words per minute. So within one standard deviation. All right. Some people are really good. W represents the number of words typed per minute by a randomly selected adult. Find the probability that a random. All right. So now we're finding probability. All right. So we're not necessarily shifting anything or stretching anything like we have before. Now we're just using normal distribution. All right. Remember, we can go to a table, but I want you guys to use your calculator. So we go to second, vars, variables, distribution. That's what we go to. Okay. So we're talking about a cumulative, which means, can I get decimals in this? So it's not very discrete. So it's cumulative. So we're going to use this. All right. And they're asking me what the gorilla, get out of here. They're asking me, all right, normal CDF, enter, right here. Find the probability that if I select a person, that they'll actually type 70 or more words per minute. So on a curve, all right, if the mean is 52, it's going to be to the right of the curve to infinity. All right. So it's going to be to the right, starting at 70. So I'm going to put 70 in there, comma. Where does it stop at? We put 999, positive 999, with a mean of 52 and a give or take of 16.7. What's the probability I randomly select somebody? It's about 14% chance that I select somebody with that. All right. It says write it out using proper probability notation. Remember how we do this. The probability, P, right? W is greater than 70, right? Something like that. Something like that. Okay. Let me make sure we did that right. So it should look something like this, I believe. Yes. All right. Probability of W. Well, what's W represent? Instead of me writing it all the way out, they asked me, what's W? Well, W represents something. Cumulative random variable, I guess you could say. Greater than or equal to 70, 14% chance that happens. Okay, good. Study was conducted to learn how typing speeds varies among industries. For professionals in the legal industry, the number of words typed per minute is actually 8 more than the general adult population. All right. So if you are in a business, on average, it's usually 8 more. So we're going to say let L represent the number of words typed per minute by a professional. Okay. So L actually equals whatever W was plus 8. Describe the probability distribution for L. Well, it's going to be the exact same thing as the mean. However, can the mean get changed with addition and subtraction? I'm going to use my notes again. Here's my notes. Oh, yes, my mean can get changed. So what we're going to do, my new mean is now going to be whatever W was. Well, what was W? 52 plus 8. My new distribution mean is now going to be 60. Okay. What about the standard deviation? Well, does standard deviation get changed with addition? We're going to say in our notes, it stays the same. It stays the same, right? SD, standard deviation, stays the same. So our mother Huba, get out of here. My mean is now 60 with a standard deviation of still 16.7. I think that's what they want. Let's check our answer key. Make sure that's right. This is part B. Let's see. L has a distribution that's approximately normal. Yes, shape stays the same. I forgot to mention that. The whole probability distribution, it's got a mean of 60 words per minute, standard deviation, give or take 16.7. Very nice. Very nice. All right. Find the probability that now somebody with a new mean, same standard deviation, has 70. All right. And we'll do the exact same thing, except instead of my mean being 52, now it's going to be 60. So I'm going to do, let's see, normal CDF. I'm still looking for that 70, right? All the way to infinity, 70 or more. All right. But my mean now is 60 with a standard deviation that remains the same because I didn't multiply. Didn't multiply or divide. And this should be fine here. So the probability, if somebody, is typing 60, what's the probability of me randomly selecting one that types 70 or more? It should be a little bit higher. Why was that? Because our mean's a little bit higher, right? Doesn't always mean that's the case, but that's what happens here. Let's see what our answer is. What I say, 27? 27. Yeah, around 27.47. Is that about right? 27. Beautiful. Beautiful. And they usually go about 4 decimal places here. We could have rounded. Very nice. What's the topic about, today? We're learning about probability distribution, discrete random variables, how to get expected value, how to look for probability, things that we did. Chapter 1 using our calculator, chapter 2 using our calculator just a little bit now. And we did transformations in chapter 1, chapter 2 as well. And it's just really going back to that. What gets affected by multiplication, division, things like that. Okay. All right. Good, good, good. All right, let's go down. Canoe rental allows customers to rent canoes for 1, 2, 3, or 4 hours. X is the number of hours that a randomly selected customer, they rent a canoe based on the data collected by this company. Probability distribution is shown. Here it is. The mean is 1.8. We could test that out in our calculator, give or take, 0.762 hour. In addition to a $5 service fee, to and from the river, the customer pays $8 for every hour. So if it's 1 hour times 8, bam, there it is. 2 hours times 8, bam, there it is. 3 hours times 8, there it is. Y is the total cost based on this distribution, okay? For renting canoe X. Is Y a discrete random variable? Let's see here. So Y is the total cost of this canoe. Let's see, 8 and 1, that's still 8, 16, 3. I think we can actually get, uh, a large amount of decimals on this. Is it discrete? Okay. So it does take a finite number of values based on a chance process. X is a randomly discrete variable. Yeah. Based on chance. Y must also be. Yeah. Yeah. All of a sudden it can't be continuous. So it still is a discrete random variable. 8 times 1, yeah. Sometimes I think can it be continuous decimal? Sometimes I think of it like that, and it doesn't look like it can be. Yeah, so it is a discrete. Write an equation for y in terms of x. Well, if x, the probability of x is getting multiplied by 8, we would say y equals 8 times whatever x is, and then a $5 service fee there. So it should be 8x plus 5. 8x plus 5, okay? All right, and I'm going to talk to part C about this, the mean and the standard deviation. All right, let's see. Does the mean get affected by multiplication? Yes. Okay, so what we're going to do, we're going to take the equation of y, which is 8x plus 5, okay, and we're going to put in our old mean, 1.8. So now you got 8 times 1.8, and then we're going to add 5 to it. Let's do that. Let's make sure this is right. So we're going to say 8 times, what's it, 1.8? 1.8. That gives me 14.4 plus 5. Our new mean, because it does get affected by multiplication, it does get affected by addition and subtraction, is 19.4. Okay. Our standard deviation only gets affected by multiplication. So we're going to say 8 times our new standard deviation point, 762, and it should be 6.1, 6.0. I don't know if they rounded it there or not. All right, so that's what our, let's see if we're right here. 19.4, I think is what we got. And yes, 6.096. So the mean is I guess we're talking about money here, right? Let me go back to the original problem. Oh, yes, we are talking about money. What's the average amount of money? If somebody's spending, 1 hour out there, 2 hours out there, right? In dollars. That's right. Okay. Well, there it is. That's really what you're doing. You're taking a random variable, okay, and see if multiplication affects it, see if addition or subtraction affects it, and coming up with either a new expected value, a new mean, and a new standard give or take deviation. There you go. All right. This is a little bit harder. I might have to draw this one out. For you. I have to draw this one out. It's uniform distribution. Let me do it real quick. Hopefully you guys can see this. Uniform. Oh man, it's not letting me do it. Come on. Let me do it. Okay, there it is. Uniform distribution, which means every scenario, whatever we're talking about here, has an equal chance of being selected. I got to plug in my computer just a second. So in uniform, a little bit different than normal distribution. Everything has an equal chance of being selected, right? That's what uniform kind of means. And this question kind of deals with uniform probability, right? So we usually draw a box. And how did I get that box? Well, didn't we do this in, earlier chapters, 6.1, 6.2, something like that. Okay. We just got to go back and look at our notes that when we look at uniform probability, all we're doing is basically multiplying here. All right, so what we'll do, we'll read the problem. Hotel guest takes the elevator from the lobby to their room on the 12th floor. Number of minutes they have to wait for the elevator is represented by M. So M by itself is the number of minutes it takes to wait for an elevator to come down. M can be modeled by uniform density, okay? It's got a density from 0 to 4. The elevator itself, to go from the bottom to the top, 12th floor, takes 2 minutes. Therefore, T represents probably the total time it takes for me to wait on an elevator, plus the 2 minutes that it takes to go all the way to the 12th floor. Okay, so let's just say, what probability distribution does T have? Well, if this one has uniform, um, if M has uniform, right, that means shape doesn't change. T has also got uniform as well. All right. So find the probability that the total time is greater than 3.5. Well, look, if M, let's just say M would be 0 all the way to 4. And I would write that 0 all the way forward. But we're not talking about M, we're talking about T. All right. So the least amount of time it's going to take is, if that was 0, T would have to be 0 plus 2, which would be 2 right here. So I would write like a 2. The lowest thing on my uniform here is 2. Okay. The highest minute that I would actually wait on a elevator, M, the highest time would be 4. The total time that it takes to get to my room is 4 plus 2, which would be 6. 6 right here. We say that in order to find probability in here, it's simply on uniform base times height. Well, all uniform has to add to 1. So 2 all the way to 6, wouldn't that be a distance of 4? Well, 4 times what would give me 1? Well, wouldn't it be 1 over 4? There we go. Something like that. Something like that. My question is now, what's the probability of me selecting a time that's greater than 3.5? So let's just estimate 2, this might be 3 right in here, right? 4, 5, 6, whatever. And let's just say 3.5 is somewhere right there. I don't know. Something like that. What I want to know is this. What's the probability of all of this shaded region right here? Well, all we're going to do is take this distance, 6, minus 3.5, or, 3.5 all the way to 6. What is that distance? And multiply it by 1/4. Let's do that in our calculator. Let's do that, and we'll check our answers, make sure we're right. So we got 6 minus 3.5. That's 2.5, right? So we're talking about this area right in here, 2.5 minutes, right? And we're going to multiply that by, I'm going to put it in parentheses. So sometimes my calculator don't do order of operations. There we go. 0.62. Ooh, there's a 62% chance. I wait to get to my room, right? Greater than 3.5 minutes. Yeah, it might take a long time. All right, very nice. Let's see our answers here. Let's just check them. T represents total time. Yes, get to the lobby to the 12th floor. I don't remember him saying that his room was on the 12th floor. Did it? Oh, it does. To their room on the 12th floor. Okay. There it is. T has uniform on the interval from 2 to 6. Okay. M has an interval from 0 to 4. We're talking about T though, right? The probability that the hotel guest spends at least 3.5 minutes getting from the lobby to the 12th floor. There we go. Very nice. We talked a little bit about uniform probability, density, and, a little bit about it. It is in your notes. So make sure that you're looking at your notes. Okay. All right. Let's keep going. Quick, 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 quick. You guys should be able to do this one. Probability distribution, number of members in a school pays it forward club in a given year shown on the table. We could get the mean, we could get the standard deviation, no big deal. Expected value, throw it in our calculator, no big deal. However, each club member must get 20 hours. So if this represents 40 members, well, if one has to get 20, how much does 40 have to give? Well, wouldn't we multiply 40 times 20? Wouldn't that be 800? 50 times 20, get an answer. 70 times 20, get an answer. The probability of me selecting will not change, in that scenario, just their hours. What's the expected number? What's the expected value? You should be able to do that into your calculator. Make sure you're looking at your notes. What's the expected number of total hours committed by each member? Okay, very nice. All right, the values in a data set have a variance of 3. Suppose the data is transformed. We didn't talk about variance as much, but if we look at our notes, when we do variance, right, we're going to multiply or divide by whatever that constant is squared, right? Multiply or divide by whatever that constant is. Well, the values have a variance of 3. All right, that's what we have so far. Suppose that it's transformed. So we're going to transform it by multiplication. This subtraction is not going to mess us up at all. So the value of each is multiplied. There it is. There's the C value right there. When we're talking about variance, hard to actually understand. We're talking about variance. We're going to take whatever the variance is multiplied by that and square it. Okay. All right. So what is 2 squared? Well, 2 squared is 4, right? And then we're going to multiply it by the variance that we have. We're going to do anything with that subtracting? Well, let's look at our notes. Does variance get affected by addition or subtraction? Nope, it stays the same. Stays the same. So our answer is going to be 4, because that's what 2 squared is, times 3. What is 4 times 3? I believe that's 12. Let's see if we're right. I like it. I like it. Very nice, everybody. Okay, that is your homework. I'm going to send this thing to you. We're going to stop sharing. There we go. Hopefully you guys understood that. Don't have the best quality here, but I want to help you out on your homework. And that will be it for now, my friends. All right. Let's.